Hello students, we'll quickly revise structure of atom. Here is the first question which is asked the number of the electrons, protons and a neutron in a species are equal to 18, 16 and 16 respectively. Assign proper symbol for the species. See over here a number of protons, like I will write a number of the neutrons, electrons and the protons. Electron minus, these are the symbols. So electron number, see these symbols, n is for the neutron, electron, the proton. So electron is how much? Electron is 18. There are 18 electrons. There are protons. How many protons? 16 protons. And neutrons are how many? There are 16 neutrons. See, number of protons is equal to atomic number. Number of protons is equal to atomic number, right? So over here, what is the atomic number? Therefore, atomic number is equal to 16. Which is the element which is having a atomic number 16? It is sulfur, right? Like generally, it is we write it this way, no? X is the symbol, Z is the atomic number, and A is the mass number. This is how we write, right? X is a symbol, right? Z is what? Atomic number, atomic number, and A is mass number. Now, what is mass number? It is a number of protons plus number of neutrons, right? So over here, what is Z? Z is 16, right? And what is the this A over here? A will be a sum of this protons and neutrons. That is equal to 32, right? And they have said that 18 electrons are there, means this is not a neutral atom. When it will be a neutral? When number of the electrons and the protons are equal, that time it will be neutral. But here there are how many excess electron? There are extra two electrons in this case, means there is a negative charge on this, S2 minus. So this is the symbol for the given question, right? There are excess of 2 electron. If it was 16 electron, then there this charge wouldn't be there. One more question we can take. Next question is how many protons and neutrons are present in the following. So first, if we consider a carbon 6 and the 12. So number of the protons is what? This Z is the atomic number. Atomic number is equal to the protons. That is equal to 6. So what is the number of neutrons? This 12 is a mass number, right? If I write this, what is this 12? 12 is a mass number, right? So what is mass number? I can write this 12 is a mass number, means 12 is equal to number of protons plus number of neutrons. So this is 12. Number of protons is how much? We know that it is 6. So what is the number of neutrons? We don't know. Number of neutrons. So therefore, number of neutrons is equal to 12 minus 6, which is equal to 6. So here, proton is 6 and neutron is 6. In the second question, what is proton? It is 26. And what is the number of neutron? 56 minus 26. So this is 30, right? As we did, 12 minus 6 is the neutron. Here, what is this? Number of protons is 38. And number of neutrons is how much? 50. Means 88 minus 38, which is equal to 50. And for this, proton is okay. You can comment this and tell me the answer for this. What is the protons and neutrons for this? We'll take a different type of example. Still, we'll take a more different type of examples. So finding number of protons, neutrons, electrons in a charged species. If there is a charged species, ions basically. Whenever atom has a charge, we call that to be a ion. Okay, we'll take this first. We'll take a Br 2 plus. This is 56 and 137. See, here, since this is not a neutral, how I understand that this is not a neutral, because there is a charge on this. Here, number of protons, here, since there is a charge, number of protons is not is equal to number of electrons, right? So here in this question, what will be the number of protons? We'll find a number of protons. It is 56, atomic number. What is the number of the neutrons? It is 137 minus 56. 137 minus 56 is how much? It is 71. Sorry, not 71. It is 81. Yeah, this is 81 number of neutrons. So here there is a Br plus 2. I'll ask you one question. If it was just Br, then how many protons and electrons? Br, then it is 56 protons and electrons is also 56. But it is Br 2 plus. 2 plus represent this 2 plus represents that loss of 2 electron. So here the number of electrons should be 56 minus 2, which is equal to 54. So how you will write a number of electron? Number of electrons will be written as Z Z minus positive charge. I will give this formula. You can remember this. How to find number of electrons is Z minus positive charge. Okay. Here if you see, uh, if it is a negative charge, okay, electron, if it is a negative charge, then you will add the electron. This is for cation. Cation means a species with a positive charge. For anions, we'll take this to a next page, right? For F minus, for a F minus, what is the number of protons? Protons is 9 and number of neutrons is 19 minus 9, which is equal to 10. But what is the number of electrons? Since it is a charged species, what you will do? Number of electrons for anions is Z plus negative charge. Negative charge, right? So what is the Z? Z is 9 plus 1. Therefore 10 electron. Number of electron is equal to 10 over here. Okay, so two formulas. If you are getting confused, you can always do this. For cation, what is the formula for finding the electron? Z minus positive charge, magnitude of the positive charge. Like magnitude is 1, no, over here magnitude is 2, no. So magnitude of positive charge. For anion, Z plus magnitude of negative charge. Can use this small relation as of now. Okay. Which of the following nucleus select the from the following nuclei select the isotopes and the isomer? What is the definition of isotopes? Isotopes are same atomic number elements. It is a relation. Elements having same atomic number but different mass number. This is isotope. Okay. And what is isobar? Isobar, elements, different element. It is different elements, different elements having same mass number, same mass number. So here where same atomic number, which is having a same atomic number, a 92 and this, they are having same atomic number, but their mass numbers, if you see, it is different. So what is the relationship between this? These are both isotope. Okay, and what is the relationship between these two? That is thorium and this. It is different. They are both different elements having same mass number. So these are isobar. Okay. So here Radio Mirchi station of Kanpur broadcast on a frequency of 13.86 kilohertz. Okay, calculate the wavelength of the electromagnetic radiation emitted by the transmitter. Which part of the electromagnetic spectrum does it belong? This is the question. So here it is just a conversion of the. This question is about conversion. It is about conversion of frequency to what? Frequency to wavelength. This is what we are doing. Wavelength. What is the relationship between the frequency and the wavelength? Is that lambda is equal to c upon nu, right? Nu represents a frequency and c represents speed of light. So c is a constant over here. Nu represents a frequency. And what is lambda? Lambda is equal to wavelength. And what is this? C is the speed of electromagnetic radiation, which is equal to speed of light, that is 3 into 10 raised to 8 meter per second, right? So what is asked? Nu is given, right? That is given to be kilohertz. Kilohertz means per second. Hertz means per second. So lambda is equal to 3 into 10 raised to 8 meter per second. And what is this? This is 1386. This is 1386 into 10 raised to, like it is this way, no? 1386 hertz. This could be written as 1386 per second, right? Hertz is also equivalent to per second. But sorry, it was kilohertz, no? It is kilohertz. 1386 kilohertz means this is what kilo per second. What is kilo? 1386 into 10 raised to 3 per second. Means over here 10 raised to 3 per second. This and this will get cancelled, right? What remains is lambda value is in meter. So this is 3 divided by 1386 into 10 raised to 8, and this will be on the numerator. 10 raised to denominator, numerator, this will be minus 3. So further 3 divided by 1386 is 0.002164 into 10 raised to 5. So what would be the wavelength? It is where it will be 1, 2, 3, 4, 5. 216.4 meter. Okay. 216, this many meter. So if this is the wavelength, to which spectrum does it belong? Okay, 216.4 meter wavelength, to which spectrum, like to which region of the electromagnetic spectrum this wavelength belongs to? So 200 to 600 is a radio frequency. Since the question is also of the radio, you can write this. This is radio frequency in terms of wavelength. Radio frequency. Radio frequency wavelength. Range is what? You can remember this 200 to 600 meter. Okay, 200 to 600 meter. So this is the answer, and it is belonging to radio frequency view. The last which part of the spectrum? It is belonging to radio frequency view. Next is a question. Calculate the energy of a photon having frequency 3 into 10 raised to 15 per second, or we can say instead of per second it is hertz, and Planck's constant is also given. So what is energy of any radiation is directly proportional to a frequency. This is from a Planck's quantum theory. So E is equal to what? E is equal to h nu. We introduce a constant h over here. This is called as one photon. This is for a one photon. This is a packet of energy. This is called as one photon. Okay, for large number of the photon, for a large number of photon, for large number of photon, this formula is what? E is equal to n h nu. N is equal to what? N could be is equal to 1, 2, 3, and so on. So here it is a photon, a single photon. So n is equal to what? E over here, n is equal to 1. H is given to be 6.626 into 10 raised to power minus 34. And what is new? Frequency is given to be 3 into 0 into 10 raised to 15 per second. So if you substitute this in a formula of the energy, energy is for one photon, no? So H is what? 6.626 into 10 raised to minus 34, and this is 3 into 10 raised to 15. So what is the answer? 6.626, 6.626 multiplied by 3. That comes to 19.87, or I'll write 88, rounding off, into 10 raised to this minus 34 plus 15. So this will be 19.88 into 10 raised to minus 19. Energy will be in joule. Why? The unit of this, if we talk about the units of the energy, N doesn't have unit, N doesn't have unit. Formula is this, right? Formula is NH nu. NH nu. N doesn't have unit over here. So this is like if you are taking this to be 1 mole, 6.023 into 10 to 23 per mole, then this will have the value of per mole. But now as of now it is just 1, so it is not a unit. So unit of this H is joule second, and what is the unit of frequency? Per second. Per second and second will get cancelled. What remains is joule. So your answer is joule. 19.88 joule. If it is asked in a kilojoule, you can obviously convert that to kilojoule by multiplying a required amount, like required multiple. Next question is based on a photoelectric effect. What it says is that electromagnetic radiations of wavelength 242 nanometer is just sufficient to ionize a sodium atom. Calculate the ionization energy of the sodium. Means, if a small part, if I show this part, this is a plate in a photoelectric effect. It is irradiated with a light, right? And this is an atom, and it ejects out the electron. This is what the photoelectric effect, right? This is a particle nature of light. This photoelectric effect proves the particle nature of the light. What is the formula? E is equal to E naught plus kinetic energy, right? E naught is the minimum amount of the energy supply required, minimum amount of energy required, minimum amount of energy required to remove or to eject the electron out, to eject the electron out. What is this energy? E is a supplied energy. E is a supplied energy, right? And this is kinetic energy. The excess energy will be utilized as a kinetic energy. Okay, this is kinetic energy. Now E is equal to what? E is equal to h nu, because one photon. Now we'll write this E is equal to what? H nu. Here energy is dependent on a frequency only and not h. H is a constant. So here, what is this h? Can I write this to be h nu naught plus a kinetic energy, right? kinetic energy. So this is the formula which we take. But here the question is not that. Question is electromagnetic radiation of wavelength 242 nanometer is just sufficient. Means over here nu naught minimum, uh, like this formula further could be converted as h c by lambda, and this is h is constant, c is constant, and a lambda naught I will write plus a kinetic energy, right? I can write it this way. So what is lambda naught given? Minimum wavelength. Lambda naught is the minimum wavelength of incident radiation, right? Here nu lambda naught is this. What about nu naught over here? Nu naught is a minimum frequency, right? But frequency is not given. So we need to find this term, no? So what will be energy term is equal to, energy term will be is equal to h c by lambda. E naught will be is equal to what? I'm just writing from this. I'm just taking this term out. That is what is told to find, no? C by lambda naught, no? Minimum energy. So H is 6.626 into 10 raised to minus 34. And what is C? 3 into 10 raised to 8 meter per second. And lambda naught is what? Lambda naught is 242 nanometer. 242 nanometer means what? 242 into 10 raised to minus 9 meter. Solve this further, right? So here, what would be the answer which will be coming is that 6.626 multiplied by 3 divided by 242. The answer comes to 0.082 into 10 raised to minus 34, and this is 10 raised to 8, and this will come in the denominator, that will become positive. So 17 uh, minus 34. So this answer is 0.082 into 10 raised to minus 17, no? 34 minus 17, right? 34 is minus 17. So this many joules will be the answer. Or you can write it 8.2 into 10 raised to minus 19 joule. This could be the answer. Minimum was asked. Next question over here is based on same photoelectric effect. A photon of a wavelength 4 into 10 to minus 7 meter strikes on a metal surface. The work function. See, this is the term which is given, work function. Work function is also a threshold energy. Threshold energy of the metal means it is given E naught. E naught is given to be 2.13 electron volt. So here the things are given in electron volt, and an answer is asked in electron volt only. Let's do this. See relation, understand this. 1 electron volt is uh, 1.6 into 10 raised to minus 19 joule, right? This is the conversion factor. You can always remember this. 1 electron volt is always equal to 1.6 into 10 raised to minus 19 joule. It is very easy to remember this because 1.6 is also a charge on an electron, no? So you can remember this formula very easily, a relation. So work function of the metal being 2.13 electron volt, calculate the energy of the photon. Means what is the energy of the photon? Means what is the energy of the supplied photon? Means if we do this, E is equal to E naught plus kinetic energy. So E is supplied energy, which is equal to which is equal to H nu, right? N is equal to 1 over here. This is H nu naught plus kinetic energy. So energy of the photon, right? So photon of the wavelength which is supplied, yeah, means over here this is what the thing means. I will still convert this H is equal to C by lambda because nu is equal to what? C by lambda. This is H is equal to C by lambda naught. and this is kinetic energy. So we are told to find this term first, right? Photon of a wavelength supplied, right? Means this is the metal plate, this is the metal plate, and this is having a wavelength of how much? 4 into 10 raised to minus 7 meter. So how you will find this energy of the photon, incident photon? Energy is equal to what? Hc by lambda. So Hc by lambda means what? Hc by lambda means what? Hc by lambda. E is equal to, what is H? H is 6.626 into 10 raised to power minus 34. C is what? 3 into 10 raised to 8 meter per second. And what is the wavelength given? Wavelength is given is 4 into 10 raised to minus 7 meter. No need of conversion. This is meter per second, and this is joule second. This is joule second, right? This unit. So after doing this, what we are going to get is 6.626 multiplied by 3 divided by 4. The answer comes to energy is equal to 4.96 into 10 raised to minus 34 into 10 raised to 8 into 10 raised to 7. So so this is 4.96 into 10 raised to minus 19. Minus 19 what? It is joule, but you are told to find in a electron volt. So 1 electron volt is equal to what? 1.6 into 10 raised to minus 19 joule. So these many joules, how many? 4.96 into 10 raised to minus 19 joule is equal to x electron volt. See, this is the simplest method we can use for the conversion. So x is equal to what? X will be is equal to, we'll do the cross multiplication. So 1 into 4.96 is equal to x into 4.96 into 10 raised to minus 19 is equal to x into 1.6 into 10 raised to minus 19. This 10 raised to minus 19, 10 raised to minus 19 gets cancelled. So x is equal to 4.96 upon 1.6, right? So 4.96 divided by 1.6. So this comes to is equal to 3.1 electron volt, right? So energy of the photon. Calculate the kinetic energy of the emission. You are told to find the kinetic energy of the emission. Means from this formula we have found out that E we have found out E naught is given, which is called as also a work function, which is equal to kinetic energy, right? So kinetic energy is equal to what? If you rearrange E minus E naught. What is E minus? What is the supplied energy? We were getting it in the electron volt, right? We were getting it in the electron volt. See, you have to take both the things in a electron volt. So this is work function. E naught over here is a work function, right? E naught is given to be 2.13 electron volt. What was the E I was getting? I was getting E to be is equal to 3.1 electron volt, right? 3.1 electron volt minus what is the minimum? Minimum is less, no? So 2.13. So 3.1 minus 2.13, this comes to 0.97 electron volt, right? Electron volt. If you want to convert this to kinetic energy, use the relation. 1 electron volt is 1.6 into 10 raised to minus 19 joule. So what would be 0.97 electron volt is equal to x joule. So after doing a cross multiplication, what you will do is x is equal to 1.6 into 10 raised to minus 19, or you can directly multiply 9.7 to this. So your answer will be 1.6. It comes to 1.552 into 10 raised to minus 19 joule. This will be your answer in joules if you are asking, right? So this is the whole question. Next question is which of the following species are isoelectronic? Which of the following species are isoelectronic? Isoelectronic means the species which are having a same electron. Isoelectronic species means a species having same number of electrons. Okay, same number of electrons. So without considering the charge, let's write this. Sodium. I'm not writing the charge. We'll write that later. So potassium, magnesium, and calcium, then S sulfur. Okay, then argon, right? So what is the number of electrons in a sodium? It is atomic number is 11, and this neutral I have written. We'll deal with this later. So it is 11. Number of the electrons in the potassium, it is 19. Magnesium, it is how much? It is 12. Atomic number is 12, right? In neutral, in neutral atom, it is what? Number of protons is equal to number of electron. Here it is 20. Sulfur is 16. Argon is 18. Now it is Na plus. Na plus means what? Na plus means here it is a removal of one electron. One electron is removed. That's why this has attained a plus one charge. So what would be the number of electron? 10 over here. Earlier it was 11, now it is 10. Potassium plus, this will be 19, so it is 18. One electron is removed. Mg what? Mg2 plus means over here 10 electrons are removed. Sorry, 2 electrons are removed. So 10, 12 minus 10 is how much? I'll write it in this form. Na plus. 11 minus 1 is equal to 10 when it is a positive charge. Here it is 19 minus 1, which is equal to 8, 18. Here it is 12 minus 2, which is equal to 10. Then calcium 2 plus. Calcium 2 plus, calcium is 20. Atomic number is 20, no? So minus 2, which is equal to 18. Then sulfur is what? Sulfur minus 2, no? Sulfur minus 2. Sulfur is what? 16, right? Plus 2. Why plus 2? Because it is minus 2. 2 electrons are added. So it is 18. And argon is again neutral, no? It is 18. There is no charge on this. Plus 0. That is 18. So which are the isoelectronic? This, and this black color mark, they are isoelectronic. Then this and this are isoelectronic. So sodium plus and Mg2 plus, they are isoelectronic, and rest it is potassium plus, then Mg2 plus, then calcium 2 plus, then S2 minus, and argon. These all are isoelectronic, means this species will have same number of electrons. Here a question asked is calculate the energy associated with the first orbit of the helium plus ion. See how energy of the nth orbit of a Bohr, according to Bohr theory, is given that energy is minus 13.6 Z square by n square electron volt, right? In joules, this is one formula. Student many time get confused with this. This is one formula where the energy is in electron volt, right? How you will do this in a joules? Energy of the electron in nth orbit is in joule will be what? See, 1 electron volt is equal to what? 1.6 into 10 to minus 19 joule, right? So here in joule it is what? Minus 13.6 into 1.6 into 10 raised to minus 19. This remains same, z square upon n square and electron volt. So here this energy formula changes to how much? 13.6 multiplied by 1.6. So this is 21 point minus 21.76 into 10 raised to minus 19 z square by n square joules. Okay, I can still write this 2.18. This could be also written as En is equal to, I'll always put a final formula in the box so that it becomes very easy for you to remember. So this is 2.18 0.76 into what? 10 I can write. And into 10 raised to minus 19 z square by n square joule. So mostly this is the formula which is also given. En is equal to minus 2.18 no into 10 raised to minus 18 z square by n square joule. So one formula is this, and other formula is electron volt. Depends in which unit the question is asked. So let's solve it in electron volt. So if I want the energy in the electron volt for the helium plus ion, so this minus 13.6, which orbit calculate energy, energy associated with the first orbit, right? So n is equal to 1 over here. If it was energy was for the second orbit, n would have been is equal to 2. If energy was for the third orbit, then n would have been is equal to 3. So this is the thing. And what is z is equal to? Z is equal to, since it is a helium, atomic number for the z is 2. So minus 13.6. This is equal to, z is 2 square. This is 2 square. And this is what? Uh, n is what? 1 square. So this energy will be is equal to what? Energy will be is equal to, therefore energy will be is equal to minus 13.6 into 4, right? 13.6 into 4. It is equal to minus 54.4 electron volt. If you want to find it in joule, you use this formula. These are the two formulas which you need to focus on. These are two formulas which you need to focus on when the energy is asked. One is in joule and other is in electron volt. Okay, just focus on these two formulas. I'll just highlight this. Energy, right? Next is what is the radius of this orbit? Radius of the orbit is what? Radius of the nth orbit is 52.9 into n square by z. This is picometer, right? This is also known as a naught. This is 52.9 is also written as equal to a naught. This is also called as a Bohr's radius. Bohr's radius, that is the first radius of the first orbit of the hydrogen atom. At n is equal to 1, z also is equal to 1. So it is a helium atom. Helium atom. So radius of the nth orbit, or we'll use this small letter Rn. Okay, many of the books it will be small only. Rn is what? 52.9, and n is what for this? It is the first, no? So 1 square, and z is 2. So here this value comes to 52.9. 1 square is 1, and this is 2. So 52.9 divided by 2 is 26.45. 26.45 picometer. Later it depends whether it is asked in a meter or picometer. Then you need to convert this, right? This is the answer. Next question is based on a de Broglie wavelength. Question asked is a tennis ball of mass 6.0 in 10 to minus 2 kg is moving with a speed of 62 meter per second. Calculate the wavelength associated with this moving tennis ball. Will the movement of tennis ball will exhibit a wave character? Answer is no, because wave character is only shown by the microscopic particle like electrons and the protons and the atoms, and the bigger particle like ball, they will not show a wave nature. They will not show a wave nature because of their mass. If we look at a de Broglie de Broglie equation, that is lambda is equal to what? H upon mv. What does this say? The wavelength is inversely proportional to mass. Since ball has a much higher mass compared to that of the electron or the protons or the neutrons or the our atoms, the wavelength for the ball will be very small, right? So let's solve this question. So lambda, what is the wavelength? That is what we need to find, right? Calculate a wavelength associated with this. So h is what? H is 6.626 into 10 raised to power minus 34, and mass of the ball is 6 into 10 raised to minus 2 kg, and a velocity is 62 right? So lambda is equal to how much? Lambda is equal to how much that comes to 6.626 divided by 6 and divided by 62. So this answer comes to 0.0178 into 10 raised to minus 34, and this is 10 raised to 2. So this wavelength comes to equal to 0.0178 into 10 raised to power minus 32. So minus 32 means what would be unit? Let's check the unit of this before we write the unit. Let's check this unit also. So unit is unit of the lambda which we are finding, whether it is meter, nanometer, picometer. Let's do this. Lambda, what is the h unit? It is joules, joule second, right? And what is the unit of the mass? Kilogram. And what is the unit of the velocity? It is meter per second. See, what is joule is equal to? Joule is equal to Newton meter, right? One J is equal to Newton meter, and this is second as it is. This is kilogram, and this is meter per second. I'm just dealing with the unit. So units are also very important. What is Newton? Newton is a force which is equal to. So here I will write, since joule is equal to Newton meter. Okay. What is Newton is equal to? It is a force which is equal to mass into acceleration. So I will write mass is equal to kilogram and acceleration is meter per second square, and this meter and s as it is, and this is kilogram and this is meter per second. Since Newton is equal to what? Kilogram per second square. That is a force, no? Force is equal to mass into acceleration, no? So this kilogram will get cancelled. This meter and this meter will get cancelled. What will remain over here is s raised to minus 2 meter s raised to 1, and this will also become s raised to 1. So s raised to minus 2 meter and s raised to 2. This and this will get cancelled. What remains is meter. So final answer over here is a meter, right? We can write it in a more fancy way, that is 1.78 into 10 raised to how much? Minus 34 meter. This is the wavelength associated with this. Here next question is based on a line spectra of the hydrogen atom. So the question is the wavelength of the light emitted when electron in a hydrogen atom undergoes transition from energy level 4 to energy level 2. Means energy level, I'll discuss about this. This is n is equal to 1. This is n is equal to 2. This is n is equal to 3. This is n is equal to 4. The gap, energy gap is going to decrease, so n is equal to 5 and n is equal to 6, and then this is last is n is equal to infinity. Like, so they have asked us what is the energy release when electron jumps from n is equal to 4 to n is equal to 2. Like, electron will jump, whenever electron jumps from higher to lower, energy is released, right? What is the wavelength of that radiation? That is what is asked. So what is the formula? 1 by lambda. 1 by lambda is a wave number, right, which is given as 109,677 into z square upon 1 upon n1 square upon 1 upon n2 square. N1 is less than N2, means N1 is 2 over here and N2 is 4 over here, right? That is what is the thing. Now solving this question, what is Z? What is Z for this? Okay, we'll solve this from here. Yeah. So 1 by lambda, this is what we'll invert this value later. First, we'll find a 1 by lambda. This unit is centimeter inverse. This is a wave number. So what is 109? First, we'll write this. This is centimeter inverse. So what is N1? N1 is lower, no, that is equal to 2. And what is N2? N2 is higher, which is equal to 4. And what is Z is equal to? Since this is a hydrogen atom, Z is equal to 1. right? So here 1 by lambda, 1 by lambda will be is equal to 109,677 into 1 square upon 1 upon n1 is what? N1 is 2 square minus 1 upon 4 square, right? So this is 109,677 1 by lambda is equal to 1 by 4 minus 1 by 16. So this will be what 1 by lambda is 109,677 4 into 16 and 16 minus 4, right? This is how you will do this. So therefore 1 by lambda is 109,677 into 12 by 4 into 16. So lambda will be is equal to what? 4 into 16 divided by 12 and 109,677. Like this is how you will rearrange for a lambda, no? And this is what you are told to find. So yes, so 4 threes are, and further if we solve this, 16 divided by 3 divided by 109,677. So your lambda value comes to um, 0.000. This is calculator value. You can always do some approx, put a decimal point. You can consider this value to be 1.1, 1.1 into 10 raised to 1.1 into 10 raised to minus 5. Approximately, you can consider this to make your calculation simple. 48 centimeter, right? And of course, you can write this 1, 2, 3, 4, 5. So 4.8 into 10 raised to minus 5 centimeter. You can write this way. So wavelength is this. Okay, this question is based on a uncertainty in the Heisenberg's uncertainty principle. What does the Heisenberg's uncertainty principle says that it is impossible to find the exactly and simultaneously exact position of the electron, right? Exact position of the electron and its velocity, right? You cannot find exactly simultaneously exact position of the electron and the momentum, right? So what is that formula? Delta x, this is a uncertainty in position, and delta p, this is uncertainty in the momentum, is greater than h by 4 pi, right? This delta x is what? Uncertainty in position, and delta p is what? Uncertainty into momentum. But here momentum is not given, velocity is given. This formula could be also written this way: delta x, and this is delta p is what? Mass into velocity. Momentum is equal to mass into velocity, which is equal to h by 4 pi, right? So what is this? While electron moves, mass of the electron is going to remain constant. So delta is not applicable to mass, that is going to remain constant. Delta is a difference in the velocity. Delta is applicable to a velocity, which is equal to delta h by 4 pi. So I will write this delta x into delta v is equal to h by 4 pi m. This is the formula we have to use over here, right? What you are told, calculate uncertainty in position, means delta x is given, uncertainty in velocity is given, mass of the electron is also given. So therefore delta x, I'll write it over here, the delta x is equal to h upon delta v 4 pi into m. So h is 6.626 into 10 raised to power minus 34. Delta V uncertainty in velocity is 5.7 into 10 raised to 5 meter per second. And 4 is just a number, pi is also a value 3.14. And mass of the electron is 9.1 into 10 raised to minus 31 kg, right? And you solve this, and answer will be 6 divided by 5.7 divided by 4 divided by 3.14 divided by 9.1. Answer comes to 0.00001. 0.01017 into 10 raised to power minus 34. This is 10 raised to 5 and minus 5 I mean, and this will be 10 raised to 31. So 0.0 uncertainty in position is 1017, and this is 10 raised to minus 39. Minus 39 and 31 is minus 8 meter. I can write this 1.017 into 10 raised to minus 10 meter. I can write, and also I can write 1.017 angstrom. That could be the also answer for this. So answer is this. Here write the subshells corresponding to following quantum number. See, I'll give you n value is equal to n can go values from 1, 2, 3, 4, 5, 6, and so on. Means n is equal to 1 means it represents the first shell, K shell, L shell, M shell, N shell, that way. It represents a principal quantum number. N represents what? A principal quantum number. It represents principal. PAL means this is something main principal quantum quantum number, right? And what is L is equal to? L is equal to L could be is equal to 0, 1, 2, 3, and so on. Means L is equal to 0 means it is s orbital, L is equal to 1 means it is p orbital, L is equal to 2 means d orbital, and L is equal to 3 means f orbital. If you know this, you can easily figure out. So n is equal to 4, L is equal to 0 means it is 4 s orbital. If n is equal to 3, n is equal to 3, so 3 and L is equal to 2 means it is 2, 2 is equal to L is equal to d, no? So it is 3d, yeah, 3d orbital. Then C 4 p orbital. L is equal to 1 means it is p orbital. Then option D is 3D. Okay, this is repeating. No, this is repeating. Option D is repeating. And option E is equal to what? N is equal to 3 and L is equal to 1. So it is 3p orbital. Then F is equal to what? F is equal to like N is equal to 4 and it is 4p orbital. Okay, this is also repeating. This is also repeating. So this is the thing regarding this identifications of the orbital, and it is very simple. You can easily take 1 marks from this. Next question is which of the orbital do not make sense? Okay, which of the following orbital do not make sense? So here it is written first is 7p. Means over here what is n is equal to? N is equal to 7. Means what would be possible values of L? L will be 0, 1, 2, 3, 4, 5 and 6. Why? L takes values from 0 to n minus 1. Remember this. L take values from 0 to n minus 1. So in seventh orbit, which are the orbital present? S, P, D, F, and till L is equal to 6. These orbitals are present. So 7, this is representing S and L is equal to P. Means 7p orbital. This is possible. This is possible. I'll mark that with a green color. This is possible. 2D. Let's talk about 2D. Is it possible? 2D means n is equal to 2. Then what are the possible values of L? L will be 0, 1, 0 and 1. Means in second shell, there is S and P orbital, there is no D orbital. So over here, one more thing we can identify is that in 2D orbital, n is equal to 2 and L is also is equal to 2, no? So principal quantum number and a azimuthal quantum number, remember this rule. So n and L cannot be cannot be same. So this orbital, 2D orbital doesn't exist. What about 3s? 3s means what? N is equal to 3, n is equal to 3, and L will be is equal to what? 0, 1, and 2. Means this is s orbital is present no, in the third shell. Whichever shell it is, first shell, second shell, everywhere s is possible. So 3s is also possible, right? Now what about this? 3s3. What is the meaning of 3s3? Clean this. They mention about 3s3. Yeah, 3s3. Why this is wrong is that s orbital maximum capacity of s orbital is what is equal to maximum capacity is equal to 2 electrons, right? Here how many electrons are there in s orbit? 3, no? That's why this is wrong, right? For the p orbital it is how much? 6 electrons, right? D orbital it is 10 electron, f orbital it is 14 electron. It's that way, right? You should remember these numbers. So this is not possible. Then there is one more orbital which is mentioned over here is 3p y3, like p orbital overall orbital is 6, but they have mentioned about one orientation. What is the capacity of one orientation? Like px, py, and a pz. It is 2 electron here, 2 electron over here, 2 electron over here. That's why p orbital has total 6, but py3 it is mentioned. So it is py2 maximum it can go, or py1 or py2, that is possible. So that's why this is also incorrect. What about 4f orbital? 4f, n is equal to 4. So what is l is equal to 0, 1, 2, and 3. So s, p, d, and f. 4f orbital is possible, right? That's why this is possible. 1p is not possible. Why? If I write over here 1p, what is n is equal to 1 and what is l is equal to for p orbital 1? Both the principal and azimuthal quantum number cannot be same. So is the answer. Next question is list the value of the principal quantum number and azimuthal quantum number for the following. So in option A, what is n is equal to for 3s, n is equal to 3, l is equal to 0, right? In a B, 3p orbital, n is equal to 3 and l is equal to 1. C, 4d orbital, n is equal to 4 and l is equal to 2, right? Remember this S, P, D, F. This is 0, 1, 2, and 3. What L values? L value for this. So D orbital it is 2. Then D1s, n is equal to what? 1 and L is equal to 0 for S orbital, right? This is D. 5p orbital, A, B, C, D, E, 5p orbital. Here n is equal to 5 and L is equal to what? 1, right? So that is the thing. Then there is a F orbital which is a 3D, n is equal to 3 and L is equal to 2. So this is what was expected from this question. How many nodes are present in a 3p orbital? See, there are two types of node. One is radial node. I'll tell you the formula. One is radial node. Remember this formula. It is given as n minus l minus 1, radial node. And other is angular node. Angular node. Angular node is just value is equal to l, right? So here, how many nodes are possible? So total number of nodes will be what? Radial node, radial node plus angular node, right? What is the formula for radial node? N minus L minus 1. What is angular node? Plus 1. This and this will get cancelled. So total number of node is N minus 1. Now in this question, how many nodes are possible? It is not mentioned. So here, number of nodes, total number of the nodes possible is total number of nodes. You'll use this formula, total number of nodes will be is equal to n minus 1, which is equal to 3 minus 1, which is equal to 2. But if this question was like ask how many radial nodes are present, so in this case radial nodes will be present is equal to 3 minus L for the p orbital is what? 1, and this is minus 1, which is equal to 1. Radial node will be is equal to 1. How many angular node? L or for the L value for the angular node is equal to what? For p orbital L value is 1. So this is the 1. So this one and this one total it is equal to 2. Next is what is the number of orbitals present in the third shell? So formula is direct. Number of orbitals present in nth shell n is 0, n is equal to 1, 2, 3, 4, 5, 6, 7, that way it will go on. So n shell is n square, means in a third shell, for therefore number of orbitals in third shell will be is equal to what? 3 the whole square, which is equal to 9. Now you will be asking how this value is coming to be 9. See, n is equal to 3. What are the possible values of L? 0, 1, and 2. Means this is s orbital, this is p orbital, and this is d orbital. S orbital has just one orientation. P orbital has px, py, pz, and d orbital has 5 orientation, that is dxy, dyz, dzx, then dx square, y square, and dz square. So these are 5 orbitals plus this is 3 orbitals and plus this is 1 orbital. How much this comes to? Which is equal to 9, no? Yes. Okay, this next question is based on a number of electrons uh, possible in a shell. So number of electrons maximum, okay, maximum number of electrons present in nth shell is equal to what? 2n square. So means over here for the seventh shell, therefore maximum number of electron in seventh shell is 2 into 7 square, which is equal to 2 into 49, which is equal to 98 electrons. See, when n is equal to 1, it is 2 electron, right? So how it is a formula? 2n square, no, means 2 into 1 square, which is equal to 2. In second shell, n is equal to 2, it is 2 into 2 raised to 2, which is equal to 8. For third shell, it is 2 into 3 raised to 2, which is equal to 18. For n is equal to 4, it is 2 into 4 raised to 2, it is equal to 32. So this is how we can understand this formula. So this formula is very important, 2n square for the electron and n square is for the orbitals. Next is indicate the number of unpaired electrons in this phosphorus, silicon, iron. This is what? Potassium. Okay, this is potassium, not Kr. It is. Oh, okay. It is krypton. Yeah. So, what is phosphorus? If we do it for the phosphorus electronic configuration, phosphorus, it is atomic number is what? Atomic number for the phosphorus P, Z is equal to 15. According to the Aufbau's principle, it is 1s, 2s, 2p. Here 2 maximum electron, 2 electrons, and here it is 6. 10 electrons are there. So 15 are left. 1s, 2s, 2p, then 3s2, then 3p, 3, right? So these electrons, this is completely filled, this is completely filled, this is completely filled, this is also completely filled. This is p orbital. P orbital, we show it this way, no? Three orientations. So first 1, 2, and 3. Here 3s orbital will be this way, 2 electron. 2p orbital is this way, 1, 2, 3, 4, 5, 6. Here all the electrons are paired. Here 2, and here it is 2. So 3 unpaired electrons. For phosphorus, it is 3 unpaired electron. What about silicon? Silicon atomic number is 14. So electronic configuration 1s2, 2s2, 2p6, 3s2, 3p, um, 3p2, right? So in this case, this is completely filled. All the electrons are paired. All the electrons are paired. In the last case, p orbital. 1 and 2. So here, in the case of silicon, it is just 2 electron unpaired, right? Then chromium is asked. Chromium is an exception where the electronic configuration is this 4s1 3d10 outermost electronic configuration. Sorry, 4s1 3d5 means actually atomic number of the chromium. If you do this, I'll solve this according to the Aufbau's principle. Chromium Z is equal to 24. So 24 electrons I need to fill, right? So this is 1s2, 1s2, then 2s2, 2p6, 3s2, 3p6, 4s2. Till here it is what? 4s2, then 3d4. But it is an exception that one of the electron goes from here to here because d5 is exactly half filled. So here s orbital is having one electron and d orbital which has a 5 orientation has a 5 electron, 1 2 3 4 5. So total 6 unpaired electron in the chromium. It is 6 unpaired electron. Same way you can try for the iron and the krypton, writing a of Bohr's principle.